Alright, guys. So, let's get started with today. So, sorry about yesterday if my announcements were really long. I didn't realize that I spent about 30 minutes just talking on the announcement. Sorry about that. That was actually pretty super long. But there were just a lot of things I wanted to get out of the way. So today, Tuesday, the only announcement I have right now, as far as now, are just turn your homework, you guys. That's all you have to do. Just turn your homework A. If you haven't done so already, pass it down to the tutor and just turn it in. All right. No late work, you guys. Remember that. So okay, what's next? So homework. There's another homework assignment due today. We'll do tomorrow. Sorry, do Wednesday. That will be based off the material that you'll learn today. So that assignment, if you haven't done so already, print it out. Remember, do the same thing. I need you guys to print it out. If you guys printed all three things in the folder, like I told you guys yesterday, if you guys printed all those three items yesterday, then good job. You don't have to worry about printing things out. If you guys haven't, they need to go and print it out again as soon as possible. Okay. So yeah, you guys, this is really the last like really the last real lecture before the exam. So whatever material we get over with today, this is gonna be the last thing that you're gonna see on the exam. So yesterday we talked about solving equations by graphing and solving equations by substitution. Today we'll continue a little bit more of graphing by substitution, and I'll also go into another method of solving equations. It's called elimination. So those are the things we'll cover today in this class. Um, Again, if there's any questions, please email me, or if it's a if it's something on say like the topics or the material, just go ahead and ask your tutor. Ask before class, whatever. But use them. That's what they're there for. Um, so, all right. Okay, so let's get started. So today, I want to continue a little bit on just solving equations. So, all right. So I want to start off with the word problem. I know we haven't done this. We haven't done word problems at all in this class, and I kind of wanted to start integrating them. So this is my chance of putting in some word problems, because in real life, you guys, we're not gonna have a simple two equations and tell us oh, find this. Well, we need to integrate that information of how to solve equations. We need to put that in real life and use it and try to use it in real life. So let's look at this equation. All right, let's look at this question. I'm sorry. So in this question, this word problem is telling us two small pitchers and one large pitcher can hold 8 cups of water. One large pitcher minus one small pitcher constitutes 2 cups of water, and then the question wants to know how many cups of water can each pitcher hold. Alright, so let's think of this, you guys. I mean, this might be more complicated just by reading it. I'll be, oh, like, what is it talking about? How am I going to find out how many cups of water can each pitcher hold when I don't even know, like when I don't even know how much I don't even know how much the small pitcher holds or how much the large pitcher holds, right? Like I can't even, I don't even know. Like it's kind of, whoa, like it's a little confusing. But don't let it confuse you guys. Is it this stuff we're doing right here is exactly what we've been doing, solving equations since yesterday. So they just grab this question. You break it down, and it's each part. Let's just put it in let's just write it down. Just write it down as far as variables and numbers and see. And let's write this down as an expression, and that way it'll make more sense. So let's think of this. So let's start with the first sentence. It's saying that two small pitchers and one large pitcher can hold 8 cups of water. Okay, So let's write this in an equation. So the thing is, two small pitchers. I'll write two small. I'll say two small pitchers. Oops. And then it says and one large pitcher. So one large pitcher can hold 8 cups of water. So in other words, it's saying that if we add how much that the small one, how much water the small one could contain, how much of water the large one could contain, it should equal 8 cups of water. That's what it's trying to tell us. So let's write this down. Let's write this as an expression. See what it means. So let's look down here for a little bit, a little more space. Okay, so let's say let's use variables, you guys. So I'm gonna use variables to explain the how much each pitcher can how much water each pitcher has. Let's do that. So let's write this equation. Let's write down. Okay, so we have two small pitchers. Let's designate X for the volume of water for the small pitchers, plus, and we have one large pitcher, so we'll say 1, and then the large pitcher, we just use Y to designate that the large pitcher, that Y will be the amount of water that the large pitcher has, will equal 8 cups of water. Okay, this is the first equation we could write. So just, I want to explain, I know this might be confusing, but just bear with me that, look, and just really pay attention what I'm saying here. So what I'm saying, I guess I'll say this again. I'm saying that two small pitchers times the amount of water each one could contain, plus one large pitcher times the amount of water it can contain, Y, will equal 8 cups. All right. I hope that makes sense to you guys. So this is this is the way we get to explain this. So, all right. So this is our first equation. So here, let me just write let's write our first equation up here. So it's just 2x plus 1y, or just y, right? You don't have to write the 1. Will equal 8. Okay. So now let's look at let's look at the second part of the question. It says one large pitcher minus one small pitcher constitutes 2 cups of water. Alright, so let's take that sentence and break it down into an equation. So, okay, so let's see, look at this. So one large pitcher, so remember we said that here, I'll write it right here. We decided, it doesn't really matter which one you guys use, to be honest, you guys. Like, you could have used Y for the small pitchers, X for the large pitcher. It just make sure that whatever variable you designate to, make sure just be consistent with that variable. Does that make sense? So if I say Y is going to be large pitchers, then Y is going to be large pitchers, and both my equations I put this in. So don't be switching variables around halfway through an equation and then say, oh, well, this one's going to be for this and this one's for this. No, like, decide at the beginning of the question what each variable is going to stand for, and that way you just be constant by using that variable. So let's look at this. So anyway, so let's look at the second part. So one large pitcher minus one small pitcher constitutes 2 cups of water. So it's pretty much just telling us that 1y, remember y is our large pitcher, minus one small pitcher, so remember our small is going to be x, equals 2 cups of water. And then lastly, let's look at what our question's really asking us. It says how many cups of water can each pitcher hold? So it wants to know, pretty much what it wants to know is how much water can small pitcher hold and large pitcher hold, or it pretty much just wants to know what values are for X and Y, since we designated for them. So it wants to know what value for X and what value for Y. That's all it wants to know. So this is going to be our equations right here. Now all we want to do is solve for these equations, you guys. That's all we want to do. So let's look at this equation. Alright, so right now we've only learned about substitution. To solve this by substitution, so let's go ahead and solve this by substitution. Once we learn about elimination, you could really use any method you want in these word problems. But for now, since we've only learned substitution, let's only do this in substitution. So okay, so let's hold on, let me just make some room. I didn't really make myself room right here. Give me a second. There you go. Okay. Let's see. All right, there you go. Okay, so now let's solve this equation. Okay, so let's do this. So we're doing substitution. So remember, you guys from yesterday, substitution. What do? We substitute one equation into another equation, and then solve for one variable, and then use that variable to solve for the other variable. Okay, so let's look at equations 1 and 2. So you could do really whatever you guys want. You could solve for y on the top one and then plug that equation into the second one. You could do that. Or you could solve for y on the bottom one, plug it on the y on the top one. You could do that. Or you could solve x on the top one and plug into the x on the bottom one. Or you could solve x on the bottom one and plug into the top. So really, you guys, there's no right or wrong way to substitute these equations. Just make sure you're consistent with what you're substituting in, and you know how, and you're making sure that you're solving for the variable is correct. Okay, so it doesn't really matter. You could go either way. I think it's well, it doesn't really matter. I kind of want to do this equation. I kind of want to solve this equation for y. So let's go ahead and do that. So this equation, I want to solve it for y. So if this second equation I'm gonna solve for y, it's gonna look something like this. Y equals, remember this x we added by itself to on this side. So this becomes y equals 2 plus x. Alright? Remember, this is the same equation as this. It's exactly the same equation. It's just rearranged to solve for y. Okay? That's all it is. So let's go ahead and plug this new rearranged equation to the first equation. Let's go ahead and do that. So we got our 2x plus our 1y, or just y, remember? So let's put that in parentheses. So it's 2 plus x equals 8. And let's just solve for this equation. So parentheses, there's nothing we could do inside the parentheses. So let's take off the parentheses. So now let's take it off because it really doesn't matter. So I'll take this one off, take this one off. Oops, I deleted the 2. Okay, and then let's just combine like terms. So we got an x right, you got an x right here, an x right here. Let's add those two, which becomes 3x. Bring down the 2 plus 2 equals 8. Now let's get rid of this 2. Let's bring it on this side. And then if I write this over here, this becomes 3x equals 8 minus 2 is what, you guys? 6, right? And let's just solve for x. So let's divide the 3, and then finally we get x equals 6. Alright, so this is, we already solved for x. We already know. So let's look at it. What do we say x was? What picture was, the small picture or the large picture? So let's look at where we designated our variables. We said the x was a small picture. So we already know that that's for small pictures, that x is going to be 6. So it's going to be 6 cups of water for each small picture. That's pretty much what it wants. That's pretty much what it's saying. Okay. Let's see. Give me a second, you guys. So we have our x, and now let's plug in our x to, it doesn't really matter which equation, you guys. We can plug in x to any equation and solve for y. Okay? So if we're assuming that x and y should be the same in both equations, remember we said that? We talked about that yesterday? Then we could either plug it into this equation or this equation, and then we will get our y. Here's something I want you guys to think about here. So if I'm telling you that this equation is the same thing as this equation, just rearranged, then why don't we just plug in x in here in this equation, because this equation is already solving for y. Why don't we just plug it in there, you guys, and then we'll get our answer. Well, let's do exactly that. So let's see. So let's plug in the x in this equation. So it's gonna be y equals, oh wait, hold on, you guys. Hold on. I think I might have made a mistake. Hold on, give me a second here. Oops. I did make a mistake. Sorry, guys. I made a mistake. I made this doesn't equal 6. Sorry, guys. 6. So I knew something was off. So let's look at this equation. This is where I'm sorry, I messed up. So 6 divided by 3. I'm sorry, this isn't equal 6. That means equals 2. What am I talking about? Okay, sorry about that. X equals 2. I was thinking about it too. I was like, how does this x equals 6 if we're talking about if we're talking about those pictures are small, right? I'm sorry about that. So anyways, oops, that is my fault. This x equals 2. Okay. So now, all right. Okay, so now let's look. Okay, let's do the same thing. So let's plug in this x equals 2 into this equation right here, because we're already solving for y. All right, just go ahead and do that. So let's plug it in. So y equals 2 plus our x is 2, and then our y is 4. And that's it. And now we found our x and y. And then remember, you guys, if we want to double check if our x and our y are correct, then we plug those variables in to this equation and to this equation, and if we get if say we plug x and y into the first equation in here, if we plug x and y in the first equation and we get 8, because remember we're talking about 8 cups of water, then hey, we found the solution. If we plug it into the second equation in here and we get 2, then we found the solution. So in this situation, since this is a word problem, you guys, so I don't want you guys to write this in an ordered pair or leave it as x equals 2 or y equals 4, because I'm not going to know what you're talking about in the homework. So I want you guys to write it out for me, all right? So let me scroll down a little bit here so that way I have some room. So if you know x is 2, remember we said x is small picture, so you just write down, let's write down small picture holds 2 cups of water, right? I mean, just 2 cups. We're talking about a measurement here, so just talk about it holds 2 cups. You could just write it like that. I mean, it doesn't really matter how much water, I guess, because you could really, it doesn't have to be water. It could be anything, right? So you could just write, and then the small pitcher holds 2 cups, and then the large pitcher, so just put large pitcher holds, and we look at our variable we designate for large pitcher, and it's 4. So 4 cups, and that's how you would answer that question. All right. So when we're doing word problems, you guys, please don't just write down, oh, x equals 2, y equals 4, and I'm done. No, you need to integrate it to what the question is asking. And this question is asking, how many cups of water can each pitcher hold? And that's why I answered it. Well, the small pitcher could hold 2 cups of water, and the large pitcher could hold 4 cups of water. Don't just box x and y in and say, oh, well, x equals 2, y equals 4. That doesn't tell me anything, you guys. So when we're talking about word problems, I want you to write it out, you guys. Write it out. Tell me what each number means. Okay, because if you just write this, and I'm not gonna know what you're talking about. I'm not gonna know what is X. You guys, I mean, what you designate X for? What you designate Y for? Like, what does that mean? I mean, you could have easily designated. Remember in my example, we said Y was a large picture. You could have easily said Y was small pictures, and then what am I supposed to assume that I know what you're talking about? Well, I don't, right? So don't when you're in a word problem, don't write things like this, right? Don't, because I mean, you did the math is correct, but we don't know what you're talking about. Okay, so in word problems, you have to write them out, like this, explaining, answering the question. So remember, at the end of the day, you guys, you're just answering the question. It doesn't matter what data you get. Say if you're doing an experiment, it doesn't matter what data you get. It doesn't matter, like all those numbers and equations. They don't mean anything if you don't put any context to them. If you don't, you don't put any words to them. They don't mean absolutely nothing if you don't explain them. So I just want you guys to get used to that. So for this specific word problem, this is our answer. If you guys have any questions, just ask the tutor. Just pause the video real quick and ask the tutor. Again, anyway, that's one of the. Let's do another word problem. All right, I want to get you guys used to doing word problems. I mean, I'm not gonna put that many word problems because I know we haven't gone over them that much, but it's something I want you guys to start doing. Okay, and start getting the hang of how we solve these problems. Okay, so all right, so let's look at our next problem. Hold on, before I go to my next problem, I just wanna hold on. I just wanna add a few more pages because then I run out and then I have nothing to write on. All right, there you go. Okay. All right, so let's look at our next problem. So it says a test has 20 questions worth 100 points. Okay. The test consists of true and false, true/false questions worth 3 points each, and multiple choice questions worth 11 points each. How many multiple choice questions are on the test? All right, you guys. So before I even do this, I want you guys to try it first. I want you guys to first set up this equation. I know this might take a little while, and this might be fairly new for you guys, but set this equation up first. So set up the expression. Remember, there should be two expressions in this problem. Set each expression up first, and then solve it. All right. So I mean, you guys could take you could take a good maybe 10 minutes to think about it, or I'm just saying 10 minutes because I want you guys to really just sit down and think about it and write it out and solve it. So if you guys could just pause the video for maybe about I don't know 8 or 10 minutes, or if everybody's done before, then that's awesome. You guys could just start the video again. But just give yourself like a few minutes just to think about this, write out the two expressions and solve for each variable. So go ahead and pause the video and then just press play so we could do the solutions. All right, you guys. So I hope everybody's done. If you guys are not done, like, we gotta keep moving on, you guys. So I think max just 10 minutes. It's maybe a few minutes on this question, maybe 8 minutes, 10 minutes at most. So let's get started. All right, let's think about this, you guys. So let's break down what each thing in this word problem is telling us. So let's think if a test has 20 questions worth 10 points. So a test has 20 questions, okay? And it says the test consists of true/false questions worth 3 points each, and multiple choice questions worth 11 points each. So let's think about this, you guys. So it's saying the test consists of true and false questions. So let's write this down. So the test has, hold on, let me get my pen. Okay, so the test has true/false questions and has multiple choice questions. So I'll just write M for multiple choice questions. Okay, so let's look at our first sentence right here. A test has 20 questions worth 100 points. So let's think about this, you guys. So no matter how many questions we need to do, we're worth 100 points. All right. So this one we kind of have to look around to on the second sentence to connect the first sentence, because the first sentence is just telling us how many points in total and how many questions in total we're looking at, but it's not telling us it's not telling us what combination of true or false and multiple choice. It's not telling us that. So let's combine these two. So first of all, let's look at the amount of questions. So saying it's 20 questions. So let's write an equation. So whatever we want to do, we want to find that the combination of true and false, and multiple choice questions will equal to 20 questions. That's all we want to do. So let's designate. First of all, before we move on, let's designate variables to each one. So for true and false questions, true and false, let's designate x, and then for multiple choice is designate y. Let's do that. Okay. So now let's do our first. Let's do our first expression. The first expression, I'm just writing an expression, just pretty much just telling you that there's 20 questions, and those 20 questions consist of either x or y. Okay, that's all I want to do. So 20 questions. Well, if we add how many questions we have at x and how many questions we have in y, then we should get 20 questions. All right. So if we know how many questions for, say, like true and false we have, then we'll find out how many questions for multiple choice we have, right? Or vice versa. If we know how many questions we know for multiple choice, we could figure out how many questions are for true and false. So we've already set up our first expression. All right. So now what's the next thing? What's the other piece of information it gives us? Now it's telling you. So you look in the first sentence, it says 20 questions and they're worth 100 points. So in total, these 20 questions will be worth 100 points. And then in the second part of the sentence, it's telling us that true false questions are worth 3 points each, and multiple choice questions are worth 11 points each. All right, so we could write that out. So the test has to be out of 100 points, and it's telling us that true false questions are out of 3 points each. So we're at 3. We'll use x for, remember, the true false, plus 11 points for the multiple choice, which is y. Let me just put this here. Okay, so let's look at our second question. Let's maybe look at it a little closer so you guys understand why I wrote it this way. So I'm saying that for x, that's true and false. So we're saying that depending on the amount, so say depending on the amount of true or false questions, they're each worth 3 points. That's what I'm saying right here. And then if you look on the other variable, it's for y, that's multiple choice questions, right? So depending how many multiple choice questions we have, they're each worth 11 points. So if we add the amount of points we have for multiple choice and the amount of points we have for true and false, we should get to our total score of 100 points. Okay, so that's how we write these two equations. So now let's do, really the hard part is just setting it up. The easy part is just solving it. So we already got done with the hard part. So let's solve this. Let's solve for x and y. Okay. So like I said, you guys, is do substitution. Like you could really, like you could either, like I said, you could either solve for x in one of them or solve for y in the other one and plug it into the second one, or do it vice versa. It doesn't matter. Okay. Really, guys, it really doesn't matter how you guys do it. Just as long as when you guys are putting, like moving variables around, moving numbers around across the equal sign, just make sure it's correct. All right, remember, keep in mind that these are still expressions. So just so you guys remember, everything we learn in math is built on each other. Okay, so that's why it's really important that if you guys are struggling with solving equations and simplifying equations and moving things around with equal sign, it's really important that you guys understand that first before you're able to move on, because then we're going to get into examples like these and you guys are going to be even more confused. So If you guys are really struggling on your expressions and how to rearrange them and how to solve for each variable, then you guys need to find some more practice. All right, you guys. So you need to talk to me, and I'll give you guys more practice. But you guys need to understand this in order to understand today's topic. So, okay. Anyways, so all right. So let's solve for one of them. We could really do we could solve this equation for x or y, or solve equation 2 for x or y. It really doesn't matter, you guys. We could do, either one. So I'll just highlight this so like you guys know I'm talking about the number. So it's not part of the equation. Okay. So what I'm gonna do is the first equation. So equation number 1, I'm gonna solve that equation for, let's say, it doesn't really matter. Let's say I'm gonna solve it for y because we've been doing it for y. So this first equation, I'm gonna write it down here. And I'm gonna solve it for y. So I mean, I'm not gonna do all the math. I'm just gonna show you guys what the equation for y should be. So it's gonna be y equals, let's see, 20 minus x. All right. So this is the rewritten form of equation 1 solving for y. All right. That's all it means. So let's plug in the solution for y. Oops. Sorry. Give me a second. Okay. Let's plug in this solution for y on the second equation, and then we'll figure out what our x is. Okay, so our second equation, we have 100 equals 3x plus 11, and then times y. Remember we said our y, where y is going to be this, so our y is going to be 20 minus x. And then let's just solve for x, you guys. So let's distribute this 11. And then if we distribute this 11, we should get, I think we should get something like 220, I believe so. And then let's distribute this 11 to the negative x, comes negative 11x. Right, and let's bring down the 3x, like that. Hold on, give me a second. Okay, sorry. So, all right, so we rewrote our equation. So now this is out of 100. Hold on, let me just make this a better plus sign. I don't want you guys to get confused. All right, this is gonna be plus that. Okay. So now let's just combine like terms and solve for x. Let's do that. So let's move this. Let me move this down. So let's combine this 3x and this 11x. So we get, what do we get, you guys? So what's 3x minus 11x? We get it is 8x, right? Negative 8x. Bring down the 220. It's gonna be equal to 100. Okay. All right. Let's get rid of the 220 on this side, so we could get x by itself. Move it over here. And then what do we get? So we get negative 120, right? Equals negative 8x. And lastly, let's just solve for x. So we divide the negative 8x. Divide right there. Divide on this side. And then, let's just divide this. So what do we get, you guys? We get, so negative 120 over negative 8. We should get x equals positive 15. All right. So I hope I didn't mess up my math this time. So sorry about that. Sorry for the last time. But so we got our x equals 15. Okay. So we already know what x is. So just so you guys remember, just so you guys didn't forget by now already. Remember what we said x is? Remember we said x is the number of true and false questions. All right. So we already know one thing. We already know that there has to be 15 true and false questions. That's one thing we already know, you guys. 15 true and false questions. All right. So All right. So without even, so think of it like this, you guys. Without even plugging this into an equation. I mean, we'll plug it into an equation just to prove a point. But think of it like this, you guys. Let's look at the question. What it's telling us. It's saying that the test has 20 questions. And if I already know that there's 15 true and false questions, then how many multiple choice questions are there, you guys? Well, think about it. You have 15. How many more questions are left on the exam to equal 20? It's 5 questions, right? So those 5 questions has to be as multiple choice questions. So there you go. Without even finishing the math, you already kind of figured it out, just by thinking about it. It's that easy. But just to for the sake of putting this in math terminology and solving for the other one, let's plug this into an equation and solve for y. All right. So remember we said that this equation is just the same thing as this equation, just solving for y. Well, this equation is already solving for y, so why don't we just plug in our x in this equation and solve for y? So let's do exactly that. So we do y equals 20 minus the x is 15, and y equals 5. And that's our answer for this next one. So we said that y equals 5. We said y is multiple choice questions and x is true and false questions. So in other words, if we write this in words, you guys, if we write this in words, you guys, the question, so remember, let's look up what the question is asking us. So let's go up here. Remember, the question is asking us something very specific. It's asking us how many multiple choice questions are on the test. So think about it like that. It's not telling us that how many true and false questions are there. Our answer is not going to include, you're not going to write down, well, there's 15 true and false questions and there's 5 multiple choice questions. I mean that's right. The whole thing is right, but that's not what the question's asking you. It's just asking you only how many multiple choice questions are there. Only multiple choice questions. So that's all you need to know, you guys. So and since we already solved multiple choice questions, remember we said there's 5 multiple choice questions. So let's write this down here. So just write down 5 multiple choice. I'll just put Q for questions, and that's our answer. All right. So I mean, don't just do don't go around just doing meaningless math just because you think that you need to solve for each variable. Sometimes you really only need to solve for one variable. That's all I ask. I solve for both variables just to, just so you guys could see, just so you guys could practice and see, that our substitution. But with questions like this, you could just literally just plug in to solve for one variable. And that's it. All right. So in this question, they're only asking us about multiple choice, not about true and false. So remember we said our y is multiple choice, so there's 5. Remember we got y equals 5, so therefore that's why there's only 5 multiple choice questions, and that's our answer for that question. So I'm gonna have a few of these, you guys. I'm gonna have a few word problems on the homework today, so don't freak out. This is confusing. I know it takes a little while, kind of turn words into expressions, but since this is a very condensed course, you guys, I don't have a lot of time to go over a lot of examples on word problems. I'm really sorry about that, but this is something you guys should practice on your own time and practice during the homework. If you're confused on how to set these expressions up, again, you guys have your tutors. Use them, ask them. Email me and I'll explain also. The hardest part of these questions are just setting them up as expressions. That's really only the hardest part of the equation, because after that you could just simply just solve for each variable, right? Just substitute. That's it. So again, these are word problems, and start getting used to them, you guys, because come around when you guys take your SATs, ACTs, or like those standardized exams. I mean, a lot of questions in math are gonna be word problems, you guys, and you're not really gonna have a lot of. I mean, you're gonna have a half and half. You're gonna have half, of you're gonna have you know equations where you have to solve, and there's gonna be other half of where it's just word problems, and you have to put those words into into an equation you could solve. So I know this. I know if you guys are not used to this at all, I'm sorry, but this is something you need to start getting used to. Writing words into pretty much translating words into math. That's what you have to get used to doing. Okay. So and then I know a lot of and if many of you are going into engineering or I say engineering because that's the only career that I could really think of. I don't know what other. I know there's many other careers. I mean, anything that's got to do with science, anything that's got to do with technology, anything. And when you're solving for certain problems, um, they're gonna be given a problem, verbally. They're gonna tell you, oh, blah blah blah, this, whatever, and you have to write an expression to it so it falls for that. So especially you guys take physics. Physics is a lot of just, you're gonna get a lot of word problems, and you have to set up your equations and solve for the variables that are missing. So physics, so at least the physics I took was a lot of algebra. So if you guys are gonna have to take physics even in high school or in college, you guys really need to understand how to translate words into a math to an equation. Okay, so this is gonna become really important. You guys just start. I just want to introduce this. You guys can start getting used to this, but you need to understand that math is meaningless if it doesn't have any context to it. So I mean, we're in real life, we're not just there solving for y, solving for x. There's no. I mean, what situation do we have where we're just are solving for a variable x, y? It doesn't mean anything if we don't designate what x, y stands for. All right, and it doesn't mean anything if we don't explain what each expression stands for either. All right, because in the end of the day, if we don't put any context to our math, then it's just it's just meaningless equations. It's just random numbers that equal random variables, and it doesn't mean anything at the end. So I know we haven't really gotten into context of each question because what a lot of this math is, we're just trying to teach you the rules of how to simplify equations, how to graph inequalities, how to find solutions, how to write them in y-intercept form. All those things are just the rules you need to apply them to real life problems such as these. So, anyways, so you guys just start getting used to that. Okay. All right, so let's move on to our next topic. So I just wanted that's pretty much the end I wanted to get with substitution, and because I wanted to mix it in with these word problems. Once we learned the new method called elimination, solving by elimination, you could also use elimination to solve these word problems. It doesn't matter, right? But on the exam and on the homework, guys, read the instructions, all right? Because I'm an instructor. In instructions, I'm gonna say specifically, okay, I want you to solve these equations using substitution, or I'll say I want you to solve these equations using elimination. And you guys have to pay attention because I'm gonna grade you not only on your answer, but I'm gonna grade you on the method you use. And if you use the correct method and you use it correctly, then that's how you're gonna get the full points. If for example in the homework, I know yesterday half the homework was solving two equations using substitution. If you didn't solve them using substitution, you did something else, and even though you got the right answer, I have to mark it wrong because you're not following what I'm telling you. I'm telling you solve it using substitution, not don't just give me the answer. So actually solve it. So today, the other half the homework actually most of the homework is just going to be solving by elimination. And when I'm talking about elimination is, if I tell you solve by elimination, then I want you to solve by elimination. Don't solve by substitution, solve by elimination. So read the instructions. Even if you got the right answer, that's good, but you're not I mean, in the end of the day, it doesn't matter, you got it right. But I want to see that you know how to do both ways. That's what I want to see, all right? I mean, and at the end of this course, really, you could choose really any way you guys want to, whatever, which I mean, you can choose any process that makes it easier for you guys. If you think substitution is going to be easier or elimination is easier for you guys, hey, go ahead. But I need to see that you guys understand how to use both of them. Okay, that's just an extra thing I want to push you guys into this class. I want you guys to know how to do both both ways of solving equations. All right, so let's continue because I'm already at 45 minutes in my clock, and I don't want to, just go off on a rant like yesterday. So, okay, so let's go on to our next topic. Now we talked about solving by graphing. Now we talked about solving equations by substitution. Now we're going to talk about solving by elimination. All right, guys. So what does this mean? Remember yesterday we talked about what substitution meant, and I mean substitution pretty much, the word substitution pretty much tells us what we're going to be doing by solving this equation, right? We're going to be substituting equations into equations to solve the answer. So what do you think elimination means? Think about it for a second. Elimination. What is elimination? Elimination means to eliminate, right? It means to get rid of. All right. So if I decided someone was being completely rude in my class, and I told them to leave, what am I doing? I'm eliminating them from my course, from my class. All right. So it's getting rid of. That's all it is. So what do you think that means as far as equations? Well, think of it like this. So we have y equals a negative x plus 2 and y equals x minus 5. So if we're saying that we're going to solve these two, we're going to solve x and y for both equations by using elimination, it means that we're going to eliminate one variable to solve for the other. We're not substituting variables, we're eliminating variables to solve for the other one. Okay? So you guys think of it like this. So when we're solving by elimination, you need to think of this equation and this equation. Think of them as numbers we're just gonna add these equations together. Okay? So keeping it the same format it is, it's just write our line down here, and we're gonna add. Oops, and we got a better addition sign than that. So we're gonna add these two equations together. That's exactly what we're gonna do. So if we're adding these two equations together, we gotta remember we still have to add them using like terms. We can't just add a 2 and an x together. We have to add a 2 with a 5, an x with an x, and a y with a y. Okay, so looking at this equation, let's add these. And we could these equations like these are additive, so we could add them. So let's go ahead and add these two equations, all right, you guys? I mean, I know you guys are like, what do you mean by add them? It's so confusing. They're two different equations, but just look, just do as a, just do what I do, all right? So I want to start on this side first, all right? Because when we add, we always start on the right. So okay, so 2 minus and negative 5. What's 2 plus 2? I mean 2 minus 5. What is that? It's just negative 3, right? And then let's look at the next one. Negative x plus x. What do we get? Negative 0, right? We eliminated that variable. That's 0. Equals, we'll bring down the equal sign. What's y plus y? We get 2y. Okay? And then lastly, all we have to do, you guys, is let's rewrite this equation real quick. So now we got 2y equals, remember, x got canceled out. This is what I mean by elimination. I mean, we eliminated one variable. So x is eliminated. So now we can just solve for y. So then let's bring down the negative 3. Solve for y. So we divide the 2 on this side, divide the 2 on this side. And we get y equals negative 3 over 2. That's the solution we got for y. Okay? And then this step is exactly the same thing we've been doing in substitution. So now since we know y, and we know that y has to be, if y has to be the same value for both these equations, and the x has to be the same value for both these equations, then let's just plug in y into one of the equations and solve for x. All right? It doesn't matter. We could use the first equation, the second equation. Doesn't matter which equation we use. But let's set up one equation. I want to set up the second. I want to set up this equation to solve for x. So I want to do this. I'm going to rearrange the second equation to solve for x. That's what I'm going to do. Oh, hold on, you guys. Okay. All right. So, all right, I'm gonna grab this equation right here, and I'm gonna move it down here, and I'm gonna make it to solve for x. So if I rearrange it, I'm not gonna go through the math, but if I rearrange it, my equation should look like y equals, I'm sorry, x equals y plus 5. All right, you guys know how to rearrange equations by now. So x equals 5 plus y. So this equation is the same equation. It's the same as the second equation, just solving for y. Okay, so we got our y. We said our y is negative 3 over 2. So let's plug in our y into our equation. So we get x equals negative 3 over 2 plus 5. If you have a calculator, or if you guys want to do it the old-fashioned way, go ahead. Add them. I'm gonna do my calculator because I have it right here. So the negative 3 over 2 plus 5, and I got let's see. Give me a second. I got 7 over 2 or 3.5. It doesn't matter which one you guys use. I'll just use 7 over 2 because I like keeping them as fractions, you guys. I don't know why. I like them. I just like it. Doesn't really matter. But so I found out that x equals 7 over 2. All right. So now we know our y. We know our x. So now let's check this, you guys. I mean, we have to get used to checking the equation. We can't just, when you're doing an exam, you guys, or when you're doing your homework, don't just circle in, oh, this is x and this is y, and that's it. No, you guys, double check your answers, you guys. I mean, there's a way, like, you could literally do the homework and get every single one correct if you double check each one, you guys. I know a lot of you just once you're done with the answer, you just want to circle it and move on and not even look back. I mean, don't do that, you guys. Double check your answer. Plug these variables into the equations, and if the equations are true, then you got the right answer. If your equations are not making sense, then obviously you did something wrong, right? So, I mean, don't just circle it and say you're done, and double check, you guys. I mean, every single person here has the potential to get 100% on each and every homework, because in algebra, there's ways to double check and ways to know you for sure are correct. I mean, there's certain disciplines that you can't do that. It's either you're right or you're wrong, or it's like, unless you really 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 know it, then. But here in algebra, at least in solving equations like this, there's multiple ways to double check your answer. So let's plug in x and y. Let's plug in this. Well, how about this? Let's plug in this x into this equation, since we haven't really used the first equation. I want to plug in that x into the first equation, and if I get negative 3 over 2 for my y, then I'm just gonna call it and say, oh well, I'm correct. So I'm gonna do that on my calculator right now. So I have negative x. So negative x. So x, we said it was 7 over 2 plus 2. And there you go. Sure enough, on my calculator, I get y equals negative 3 over 2. So that's all you have to do for double check. You can just plug in one variable and solve for the other one. If you guys get the same variable for both equations, hey, you found a solution that satisfies both equations. So in this case, this is our answer. So let's write this in ordered pair, you guys. So I'm gonna write this. I know I write all over the place. I'm sorry about this, but it's just, I don't know, it's just how I write. Sorry, I know it's not very organized, but oh well. Well, you know what? I'll do my best. I'll write it organized. Let me write it down here, you guys. Okay, so you guys don't have to try to figure out what I'm doing. So let's write an ordered pair. So here's a parentheses. Our x is 7 over 2, or it's just, or it's 7 over 2, or you could use 3.5. That's fine. It doesn't matter. Like, I just like using fractions. Negative 3 over 2 for y, and that's our answer. All right. I mean, the middle thing right here, that's just a comma. It's just, it just came out too big, but it should be a comma. All right, guys. So that's our answer, and that's how we solve by elimination. All right. So all I want you to do is eliminate one variable, and solve for the other one. That's all I want you guys to do. Sometimes I'll tell you guys now. Sometimes you're like in this case, like in this example, x was already set up to be canceled. One was positive, one was negative. These both cancel out. But that's not always going to be the case. Sometimes neither x or y are set up to just add and cancel out. Sometimes we have to multiply the whole equation by a certain negative or maybe a certain number to to churn those variables into a way that they could cancel out. So I'll explain what that means with a few problems, you guys. So just know that in this equation, this is what I mean by elimination. All right, it's just a different way of solving for x and y. That's all it is. Like you could have done this in the substitution way and gotten the exact same answers. Like I said, I just want you guys to understand how to do both ways. So that way you guys know. So at the end of this class, and when you guys go back to high school and when you guys go into college, you guys could at least you guys know how to do either one. You guys do substitution or elimination. It's up to you guys. You guys choose. All right. It's not a right or wrong way. It's just I want to make sure you guys know how to do both. So okay. So let's do another problem. All right. Let's do a problem. Let's see. Okay. Let's do y equals, let's say, 2x plus 5 and y equals 3x plus, let's say, like 7. And let's say we want to solve these two equations using elimination. Okay, so let's look at this. Just draw our line right here so we can add them together and put our addition sign. Oh, I don't like that addition sign. There you go. Okay, so let's add them together. So first of all, before we even start adding this, we need to know that that we could cancel out a variable. That's the first thing we need to look at. So let's look at our y's. Can we cancel out the y's by any chance? Nope, right? Because I mean they're both positive, and they're not going to cancel out. They're going to add each other. So it's going to be 2y. What are x's? Can we cancel out the x's? We can't cancel out our x's either, right? Because we have a 2x and a 3x. None of them are negative, and none of them are the same number to cancel out to 0. So there's nothing we could do right now. There's really nothing we could do at this point. So let's think of it like this. Okay, well, there's nothing we could do. I mean, so we would have to convert. So, for example, we would have to convert either the 3 into a 2 or the 2 into a 3. So the numbers are the same and that they're negative and they could just become 0, right? That's what we could do. So there's really a lot of ways you guys could do this, you guys. We could say, for example, like the first problem, we could multiply the first problem by, say, like a negative. Say, like, for example, I'm using an example you could really do anyways. Let's say we want to get the y's away. I mean, it doesn't really matter. We could get rid of the y's or the x's. It really doesn't matter, you guys. So let's get rid of this. For example, I want to get this y. I always want to get rid of the y just because the y's, and I don't know, we already tried too many x's. So if I want to cancel out the y's, okay, so right now both y's are positive, right? And they're going to be 2y. What do I have to turn one y into so I could get a 0 when I add one y and add it by the other y? What do I have to turn one of the y's, what do I have to turn one of the y's into so they could cancel out? So if you guys think it's flipping the sign on one of the y's, say like one y will be negative, another y will be positive, right? Because negative y plus y or y minus y, that's just 0, right? So we gotta find a way to turn either it doesn't really matter what equation we use, either one into a negative. Alright, so let's turn the first one into a negative. So what we're gonna do, I'm gonna write parentheses on the whole equation because so you guys just understand. So I want to turn the first y on the first equation. I want to turn that one into a negative, so we could just cancel that one out. So what we're going to do, we're going to multiply this whole equation by a negative, by negative 1. Negative 1. Okay? So let's multiply negative 1. And what I mean by multiply negative 1, I mean literally multiply every single number and variable by -1. So we're going to multiply this -1 into this y, into this 2 plus x, and into this 5. Okay, so let's rewrite this over here. So I'll just draw like a little arrow saying I'm going to rewrite over here. So -1 times y is just, it's just -y, right? Equals, then -1 times 2x, what do we get? We get -2x. So pretty much everything, all the signs are going to flip on the equation. That's all that's going to happen. The lines are just going to flip. The -1 times +5 is just -5, right? Okay, so now let's rewrite this right. So now let's move this one over here. So now we're going to have something like y. Let me write it a little better. This becomes y is equal to 3x plus 7. Now let's add this. Now we could add them because we have one variable we could cancel out. So let's start from a right to left. So -5 plus 7, what do we get, you guys? We get 2, right? -2x plus 3x, we get what? Just x, right? It's just going to be 1x. Hold on. I'm still not used to writing in a touch screen. It's kind of a little weird, but just hold on. Give me a second. All right, there you go. Lastly, -y plus +y. What do we get? We get 0, right? Those two cancel out and you get 0. Okay. So then, okay, now we're down to this equation. You get 0 equals x plus 2. All right, so let's solve for x, you guys. So the 2, let's move the 2 on this side. Let's subtract the 2 on this side to get x by itself. And we get -2 equals x. And that's your answer for x. And then we could just plug this x into either this equation or this equation and solve for y. It doesn't matter. Let's plug it into the second equation, all right? And solve for y. So we now have our y equals 3x, and we said our 3x is -2 plus 7. 3 times -2 is -6 plus 7. And then, it's just an addition problem, and this just becomes y equals 1. And that's it, you guys. So now we got our x, we got our y. Let's just double check, all right? Let's just double check to make sure this is correct, and if we're correct, hey, we're good to go. So let's plug in this x and this y. Let's plug in these two variables in the first equation. That's what I'm gonna try. You could do it in either one. You could check it with the second equation. It doesn't matter, but I want to do the first one. So let's plug in the x into the first equation, and if we get 1 for our y, then hey, we did a good job. And it was correct. So and sure enough, I plug it in my calculator and I get 1 for y. So that's the answer, you guys. So let's write this in an ordered pair. So we got our parentheses. We got a -2 for the x. We got a 1 for the y. Just box it in. Bam, that's our answer, you guys. Okay. And that's it, you guys. So just remember, this is like a point you guys want to understand. When we're solving equations by elimination, you could multiply either equation by a certain multiple, either by a negative or by another number. So you could get a least common multiple of one variable. That way you can just cancel it out. Okay, so it doesn't matter what it is. I mean, so like in this case, so if you look at this in our problem, we had to multiply a -1 into the whole first equation because we wanted to cancel out y, right? I mean, we could have just multiplied the -1 into the second equation. That would have worked perfectly too. But it doesn't really matter. You could choose any one. Just be consistent with with what you're doing. So, like I said, there's really no right or wrong answer. You could do either one, but just be consistent with your math. Okay, let's do another example. So, you know what? Let's do one from your homework, because in the end of the day, anyways, I want I want you guys to understand this from your homework assignments anyway. So, let's do one from the homework assignment. Let's see. Let's see. I already have it up here. Okay. So if you look at these questions, I'm telling you, solve each system by elimination. Okay. So without even doing the without even doing the math, just look at all of these, you guys. Like look at number 6. We got negative 4x and we have a 4x on the bottom. We could just, there you go. That's already one we cancel out and solve for y. It's a simple equation. Look at number 7. There's a 4x, there's a minus 4x. Those cancel out and we can solve for y, right? Let's look at number 8. I mean, I'm just talking about this real quick so you guys kind of understand. Number 8, we got a negative 2x, negative 4, there's nothing we could do there. We have a negative y, and we have a negative 9y. We have a negative 9y, negative 9y. It'd be nice if one of them was positive. That way they both cancel out, right? So why can't we? So we could just multiply. Say we could just, for example, like number 8, we could just multiply. So you know what? Let me show number 8 real quick. That way you guys are not confused. I don't want to confuse you guys. Let's see. Give me a second. I don't know why it's not a. All right, there you go. So let's just, I'm not gonna do number y. I just want to show you guys how to set it up, but I'm not gonna go ahead and just solve it. I'm gonna let you guys do that. So let's see. Hold on, give me a second. Let me just find a good spot. Okay. So we're looking at number 8. Okay, I have it on the right side of the screen. Number 8. So, oops, man, I'm sorry. Okay, so we're looking at number 8. Okay, I'm gonna write it out. So we got negative 2x minus 9y equals negative 25. And then the bottom equation is negative 4x minus 9y equals negative 23. Somebody was saying it'd be nice if, say, one of these 9y's were positive, so there would be the opposite sign. That way they could just cancel out and become 0. It'd be nice, right? So why don't we just do exactly that? Why don't we turn one of these negative 9y's into a positive 9y? All right, we could do either one. We could do the first. We could turn the first equation into a positive, or turn the second equation into a positive. It doesn't really matter. Let's go with the first one, just because the first one's the first. It's already up there. So let's put up parentheses. And I want you to think about this, you guys. What do you multiply a negative number by to get a positive number? Think about it. Remember? So if we multiply a negative times a negative, we get a positive, right? So we're going to multiply this whole equation by a negative number. We're going to multiply by negative 1. So I'll write, I don't know if I have enough space. Let me see. So let's multiply this whole equation by negative 1. Hold on, let me just erase this. Okay? So let's multiply the whole equation by negative 1. So we're multiplying the whole equation by negative 1. What does that mean? Without even doing distributing and all that, what do you think? That's good. So it just means that we're going to multiply each variable and each number in the first equation by a negative number. Okay? So all that's going to happen is just, the sign's going to flip on the whole equation. On each number of the whole equation, that's all it means. So if we rewrite this, so I'm going to rewrite it down here. So I'm going to rewrite it down here, you guys. So this becomes, a positive 2x plus 9y equals positive 25. And then let's move down the second equation. Now let's move on this equation. We'll move down here, and now it's a negative 4x minus 9y equals 25. And what do you know? We have a positive 9y, a negative 9y. That'll cancel out, and we can solve for our x. And then we solve for x, and that's it. And then we plug that x. Then we plug that x into our original equations up here. Solve for y. What do you know? We get our y. Okay, you guys. So what you want to do, you want to find out ways to multiply each equation by so that we could cancel out terms. Okay, so that's how we do number 8. I'm not gonna solve it. You guys can solve it, but just understand that's how it's gonna work. Let's see, number 9. Okay, so number 9, you can do the same thing. There's a positive y. There's two positive y's with exactly the same value, 1. You just multiply. You can just turn one of them into a negative. So if you turn one to negative, you just flip the sign on the the whole equation and then cancel that one out. Okay. Same thing with number 10. Same thing with number 11. I'm helping you guys out with your homework right here. I'm just kind of telling you what you need to understand. Number 12. Oh, number 12 is it's kind of a different case. Let me find one that's a little more complex. That way you guys understand what I'm getting at. Because I feel 12. I mean, if you understand this next example of complexity, then you'll be for sure not at number 12. That shouldn't be a problem. So. Okay, let's try. I'm trying to think of a good one to try with you guys. One that you'd be like, whoa, I don't know what to cancel out that. Let's try like number. Yeah, hold on, let me see. Maybe this is a better one. Let's see. I'm just trying to find a good one you guys to try because I don't want to just try any one and you guys are all confused in the rest of them. Let's try like number. How about we just try like number 18? All right, guys. Let's try number 18. So, all right, I'm gonna write number 18 over here, and this will be the last problem I do, and you guys are if this is the end of class, you guys are good to go. If not, then just if you've printed out your homework assignments, you need to do them. All right, you need to do them till the end of the class. If you don't have your homework assignment printed out, then hey, you need to be doing something. I'm not gonna allow you guys to just sit there and wait till the class, and the tutors are gonna take note of that. So if this is the end of class, you guys could go, or if by the time I finish this last problems in the class, and hey, that's you guys are good to go. But so I'm gonna do this next problem, and that'll be the end of my video. So. Alright, so let's do this next. So before I get to this problem, just in case it is in the class, I just want to make some final announcements. So again, today's homework is due. So today's homework. Today's Tuesday. Turn that homework in. Turn today's homework. I think it's homework 9. That one's gonna be due tomorrow, Wednesday, the first thing in class. Okay, it's the first thing that's due. And then I hope everybody's work has worked or at least looked through their packet. I don't know. I hope at least someone has looked at their packet and done a few problems. Like, you guys don't have to do every single problem. You guys just do a few. Just do a few of each kind or do the ones that you think are the hardest for you. You don't have to do ones that are a breeze. I mean, try them because that way what if you think they're so easy and they're not? And they're actually really hard. So, I hope you guys are working on that. I'll post the key up tomorrow on Wednesday. I mean, I'll post it up early. I'll do my best to post it up as soon as possible. That is just for you guys to check your answers and then because if you guys have the key, then you guys can kind of figure it out, right? You guys know what the answer should be, and you guys can check your math, and you guys can see where you did wrong or if you missed a step or whatever. Okay. Let's see what else before I do the last question. Well, that's about it. You guys, please keep emailing me if there's any questions. I can't really think of anything else. So just know the test is still Thursday. That hasn't changed. It's not going anywhere. It's still there. Please keep studying. Study really hard. I mean, there's online resources, you guys. There's a lot of things online you could go, and there's YouTube videos. There's places where you could go and learn more about these topics. Like I said, you guys, like I say again, you guys, I don't take offense if you guys find it more helpful, looking at a video, go ahead. But you guys need to understand this. This isn't for me. This is for you guys to understand. Okay? But just know that I'm writing the test. So if I taught you a certain way to do something, or then that's a certain way I want you to do it on my exam. Okay? Just keep that in mind. Just because X, Y, or Z professor did it a certain way in YouTube. He explained a certain way and he did it another different way. Doesn't mean that that's the way I want you guys to do it. Okay. I mean, really, math is the same at the end, but you could really the answers you could express them in different ways. So just keep that in mind, you guys. So anyway, I'm gonna do this last question, and again, like I said, I hope these videos are working out. And tomorrow you'll just have a review day. Okay. So anyways, any questions? Email me. There's the tutors. You guys get it. So let's do the last question, and if you guys have to go already, if it's in the class, and get going, and if you want, you could watch this you can watch the rest of the video on your own time. You can watch the end of the video on your own time, on maybe back when you're in dorms or during tutoring, if you want to like see what the what my last example is. Fine. If this is not the end of class, if the class is still going, then hey, stick around. You have to watch the last one. But I'm just doing this just in case you guys have to leave already. So all right, so let's go ahead. Let's stop wasting time. So let's do number 18. So you got 5x plus 4y is negative 30, 3x minus 9y, negative 18. Okay, so let's do the same thing we've been doing. Let's solve this equation using elimination. We're only using elimination. We're not using substitution, you guys. We're using elimination. So let's go ahead and solve this by elimination. So okay, let's see. Can we cancel out the x's by any chance? Nope. Can we cancel out the y's by any chance? No, we can't. I mean, we have a positive and negative, but I mean, if we add 4 with negative y, with negative 9y, we just get a negative 5y, right? We're not canceling out. So this is where it gets a little tricky, because we can't just flip the sign. We've been talking about, let's just flip the sign on one of the variables and we cancel for other. So it's not as easy just flipping the sign, all right? We need to think of something. We need to think of what we could multiply one equation by, or maybe what can we multiply each equation by to cancel out a variable. Okay, so let's think of it like this, you guys. Could we multiply anything by 4 to give us negative 9? I mean we can. I guess technically you can. Like you could multiply maybe like you can multiply by 2 point something. It'll be like a fraction. It'll be like decimal. You could do that. That's fine. But on an exam you might not have a lot of time, and just to not confuse you guys, they just multiply both sides by something. So we get a least common multiple. So you guys, let's look at 4 and 9. Let's look at we could look at any. We could cancel out the x's, or we could cancel the y's. It doesn't really matter what we cancel out by, you guys. Let's try the x's. It doesn't matter. You could try to multiply the y's by certain numbers to cancel them out, or you could multiply the x's. It doesn't matter. So I want to look at the x's. Let's look at the x's first. I don't really care about the y. Let's do x's. So what's the least common multiple? Remember, the least common multiple, the LCM, which is basic math stuff. What's the least common multiple of 5 and 3, guys? What is that? It should be 15, right? So the least common multiple of 5 and 3 should be 15. Okay? Because if we multiply 5 by 3, we get 15. Multiply if we multiply 3 and 5, 15. 5 and 3 is 15, right? We're going to get the same number. Okay? Let's do exactly that, you guys. Let's multiply each side by a certain number so we could get 15. So you get 15 for the least common multiple on the x's. Okay? Let's do exactly that. I know it might sound a little confusing or like, what are you talking about? But just like I said, just watch, and just watch as I just do what I do. Okay? So let's look at the first one. So let's rewrite this whole equation over here. So we got our 5x plus 4y equals negative 30. We got 3x minus 9y equals negative 18. Okay, so then when we're gonna multiply, we have to multiply both equations, guys. We have to multiply both equations so we could get 15x on both equations. Okay. So let's look at the first equation. We got 5x. So what do we have to multiply 5x by to get 15? What do you have to do? Multiply by 3, right? So it goes 3 times 5 gives us 15. How about the second? What do we have to multiply this 3x by to get 15x? 5, right? Okay. So there's one more thing we need to do before we start distributing and everything. So if we look at this, even if we get 15x on both sides, we just have 15x, right? They don't cancel out still. One has to be a negative to cancel out. So we could, we could multiply either the top equation we could multiply by negative 3x, or the bottom equation we could multiply by negative 5x. It really doesn't matter. But since let's I don't know, let's multiply the bottom. Let's multiply the bottom by negative 5x. That way the bottom can't. But the bottom becomes a negative. But to be honest, it really doesn't matter, you guys. It doesn't matter. So let's do the math. So this 3 into the 5x, this 3 into the 4y, and this 3 into negative 30. So remember, when we have to multiply one variable by a number, we have to multiply the whole equation by that number. Okay. So just rewrite this thing. Just rewrite this equation down here. So 3 into so the first one will be 15x. And then it's going to become 3 times 4y. It's going to become positive 12y equals negative 30 times 3. What is that, you guys? That should be negative 90, right? Okay. That's that. So this one is this one. That's all it is. It's just just multiplied by 3. That's all it is. So let's multiply the second equation by negative 5. Okay. So negative 5, into the 3x, negative 5 into the 9y, negative 3. Negative 5 into the negative 18. Alright, so negative 5 times 3x is, what do we get? Negative 15x, right? And then negative 5 multiplied by negative 9, then we get positive 45y equals, and then we got negative 5 times negative 18. Remember you guys, it's negative 18, so it's, okay, I'm just going to do my calculator. Negative 5 times negative 18, we get 90. Was it 90? Oh, man, apparently we get 90. Okay. So let's look at this. Okay. So before we do anything, let's just really think about this, you guys. Really, just really think about this. Okay. So there's actually multiple things we could cancel out here, right? We could cancel if we're gonna add these. We could cancel out these 5x's, 15x's, right? Because 15 minus 15x, 15x minus 15x is just 0, right? 12y plus 45y, what do we get, you guys? It becomes 57y. Bring down the equal sign. Negative 90 plus 90 is 0. And I know what you guys are thinking. You guys are, well, we won't have anything to divide the other side by, right? Because it's just, it's going to get 0. So you guys are starting to think, oh, well, this is going to be a no solution. No. This is still a solution, you guys. So think of it like this. So let's rewrite this equation over here. So we got our 57y equals 0. Okay, let's still solve for y. All right, let's still get rid of this 57. So let's divide this 57 by itself, get rid of it, divide on this side, 57. What is 0 divided by 57? Which is 0, right? So it becomes 0. So if we write this equation, so now it's just y equals 0. Alright, so we know that our variable for y has to equal 0. It has to equal 0. So let's just plug in y, just plug in our y, which is 0. Let's plug in our y into either equation. And, first of all, let's solve one equation for x, and then plug in the y, and then we'll get our x. Okay, so this is still an answer, you guys. This is not a no solution. This is an answer right here. All right, so don't think, oh, there's gonna be no solution. No, that's an answer, you guys. So let's plug in this y into our original equation. You could plug it in. You could plug in this y equals 0 into any of these equations right here. Into these two equations right here. That's fine, but I always like to plug them into the original. So let's plug them into the original equations in here, and then let's get our x. So first of all, let's we can't just go ahead and plug in y and that's it. Let's first set up one equation to solve for x. Okay, so let's it doesn't really matter. Let's choose the first equation. This equation, I'm gonna write it over here. I'm gonna set up the first equation to solve for x. All right. So you guys, I'm not gonna get into the math. I'm just gonna show you the guys the answer. Solution should be x equals negative 30, okay, plus 4y over 5. Oops, it shouldn't be a plus 4y. I'm sorry. This should be a negative y. Okay. Okay. And then I mean, you could divide, you could distribute you could just, or you could rewrite it, that you could write it like that. That's perfectly fine with me. Or you could also write it like, you could also write it like this: x is equal to, you could put the 5. So it's 5 divided by 30, just negative 6, right? Because negative 30 divided by 5 is just negative 6. And then it's going to be negative 4 over 5y. Alright, so here we set up our equation to solve for x. Now all we have to do is just plug in our y into this equation, and then we'll get our x. So let's go ahead and do that, you guys. So we got x equals negative 6 minus 4 over 5, and our y we said was 0. So remember, 0 times any number just becomes 0, right? So this will just be cancelled out, become a 0. X equals negative 6. All right. And lastly, just like always, let's double check our answers. So we got x equals negative 6 and y equals 0. So let's plug in. If we plug in x and y for any of the two original equations, we should get whatever that number tells it's equal to. So let's plug in x and y into the second. Let's plug it into the second equation. All right. So okay. Look at my calculator. Just real quick. So let's see. Okay, we got 3, and then the x is we said negative 6, and then it's minus the equation, and then minus 9y, right? Because this y right here, 9. We said y was 0, and sure enough, I get negative 18, and that's what this is telling us. It should be negative 18. And that's our answer, you guys. And then we just write this as an ordered pair. I know I'm running out of space. I know I've run completely out of space. This is terrible, but let's write this in as an ordered pair. Let's just write it down here real quick. So an ordered pair, negative 6, and then y is 0. Box in our answer, and that's our answer. Alright, you guys. So now this is for sure the end of the video. I hope I didn't go way too over time. If you guys are watching this back at the dorm or anything, I hope that made sense. If you have any more questions, like I say, email me again. I repeat this again. Please email me, or ask your tutors. But ask. Don't just stay quiet about it, and don't just stay quiet and, well, I didn't get it, and this and that. I mean, that's really not an excuse, you guys. You need to, like, in college, you need to ask questions if you don't get something, okay? Because as the instructor or as the tutors, we can't read your guys' minds, all right? So if you guys are having a hard time and are mad because you don't get it, then hey, I'm sorry. The only person to blame is yourself, because we don't know what's going in your mind. We can't predict that, whether you know it or not. So if you guys have trouble, like I said, please ask. Okay, I hope this makes sense. And anyways, have a good day.